Hello everyone, today we are going to talk about Diols-Alder reaction. It is also called 4+2 cycloaddition. As you can see from the reaction here, you have a diene, you have a dienophile, and this is 4 carbon, and there are 2 carbons, and then they form the 6 carbon rings. So that is why it is called 4+2. Dienophile phile, as it is in nucleophile or electrophile. Phile means love. Dienophile means this compound would love diene. So they would react. And then this is the product. Yeah, the mechanism is like this. You always attack from electron-rich part. Here it is the double bond on diene. It is a concerted reaction. And then you have this. You may ask, both of them have carbon-carbon double bond. Why this is the electrophile and this is a nucleophile? That is because, as you can see, this is a electron withdrawing group. Means it will withdraw electron from the carbon. Therefore, as a result, here it would be a partial negative, and here it would be a partial positive on the carbon, and that is why it is a new electrophile. Yeah. One thing you guys need to know about Diols-Alder reaction is endo rule. Endo rules. Endo means the R group of the alkene will in this position with the R group outside of the diene. Yeah, so you can see here, this would be an endo. This is the R group from the alkene, and this is the outer R group from the diene. They would be in cis relationship. Also here as well, it's their concerted reaction. So these two would stay the same relative position as they were in the alkene. And this one here, you can see the R group from the alkene and the outer R group from the diene. They are in trans position, so this would be an exo. Experimentally, people observe that most of the cases endo product would be more favored. Yeah, so when you see a Diols-Alder reaction, you should consider the product as endo would be a major product. Another thing you need to consider about when you encounter a Diols-Alder reaction is the regiochemistry. As you can see, if you want those two compounds to react, this is a diene, this is a dienophile. It can have a lot of combination. You can have this compound react with this one, because they're identical. You just flip it, you get this, and also you can have this compound react with this one. So what would be the major product? Here you need to draw out the imaginary intermediate like this. if you react with you use those two compounds to react together, you would get this imaginary intermediate. As you can see, the partial, no, not partial, there would be a tertiary carbon cation here. It is very favored, very stable, and also you will have a negative charge here on this carbon. And since this is electron withdrawing group, it would be favored. Yeah, so this would be pretty nice. And then next step, you just use this to attack this carbon, and the double bond attack here, you would have the product. Or you can try out other combination. If you attack this from here to here, you would get this. Yeah, this is a electron withdrawing group, and this is yeah, so it would favor electron negative here instead of here, so this would be wrong. Or if you try out this compound with this compound, yeah, this is the same, you would get this imaginary intermediate. Yeah, so this part here is pretty good because this is a electron withdrawing group and there is electron, it would be very happy. And here you have a secondary carbon cation. As you can as we learned from previous chemistry, secondary carbon cation is less favored than tertiary carbon cation, so this would be less favored than that one. Yeah, so the product should be this.